Second derivatives and stationary points. Consider the curve shown here. We can see that we have a local maximum here and a local minimum here. And let's say that's the graph of y equals f of x. What would be the gradient function of the curve? So what would that be? What would it look like? So if we make an axis for that, we know that the gradient is 0 here. Therefore, the gradient function must be 0. It must be on the axis. And the same will be true at the minimum point just here. Now, let's look to the left of this turning point. The gradient is positive. So the gradient function is positive, which means it's above the x-axis. So we could draw this for part of the gradient function. Now if we consider this section between the two turning points, along this section here, the gradient is negative, which means the gradient function must be below the axis. And then here the gradient's positive again. So the gradient function should look something like this. So that's the gradient function, f dashed of x, that we're plotting there. The second derivative is the gradient function of the gradient function. So we need to do the same exercise for this one. So we're going to need another x-axis. There's only one turning point here, so that's where this should be 0. Remember, it's the gradient function of this one. So when the gradient is 0, the gradient function must be 0. If we look to the left of that, the gradient is negative. To the right, the gradient is positive. So if the gradient is negative, then the gradient function must be below the axis. The gradient's positive, the gradient function must be above the axis. So, this is the second derivative, which is the gradient function of the gradient function. From this we can see that d2y dx squared is less than 0 at a maximum point. We had a maximum point here, and if we trace that right the way down the diagram, we can see the second derivative is negative. So the second derivative is negative at a maximum point. The second derivative is positive at a minimum point. Don't worry about that, we'll come to that in a second. So at the minimum point, trace that down the diagram, and we can see that the second derivative is positive. It's above the axis. It is also true that d2y dx squared is 0. Most people think at this point you're going to say that that's a horizontal point of inflection, but that gives you no information. It could be any of the three types of stationary point if d2y dx squared comes out as 0. So that's a case where you'd use one of your sine graphs.